question number 8, we're trying to find the max min value, and so we need to come up with a quadratic relationship for this situation. So it says here a train company charges $300 to travel across Canada and usually it has 250 travelers. If they increase the fare by $10, they will lose 4 customers. Okay, so we want to maximize revenue. So first thing is we need to come up with an equation for revenue. And the equation for revenue is the price. Revenue is equal to price times number sold. So the revenue is going to be, well, my price starts off at $300 and they increase the price. So we're going to increase the price by groups of 10, so groups of $10. So I'm going to go plus 10x. So x represents how many $10 increases. And then our sales start off at 250 travelers. So 250 travelers. And we're going to decrease by 4 customers. So for every group of 10, we lose a group of 4. So it's going to be minus 4x. And then x represents how many increases or decreases we're talking about. So there's my quadratic equation. And in the previous example, we just graphed this and found the max point. This time we'll actually multiply this out and complete the square. So there's different ways to do this depending on what is available to you. So in this case, if we want to do this algebraically, we're going to complete the square. So I'm going to multiply this out. So I get 300 times 250. So 300 times 250 gives us 75,000. And then we're going to expand, so minus 1200x plus 2500x minus 40x squared. So there's our quadratic equation. So I'm going to regroup this. So I'm going to factor the 40 out. So I get x squared. This becomes plus 1300. So I'm going to go, let's see here. Maybe I'll just do that in steps. So we'll go minus 40x squared. So plus, okay, we're going to go plus 1300x and then plus 75,000. Okay, and then we're going to factor out the negative 40. So it's just going to be 1300 divided by 40 gives us 32.5x plus blank, and then we're going to add the 75,000 at the end. Okay, so again we need to complete this square, so I need to complete my square. So I'm going to start off with my x squared and the negative 32.5, so I'm going to have to divide that into 2, so 16.25x, negative 16.25x. So that's going to be our length here. And then to complete the square, I take half of the 32.5, so 16.25, and I square that value. And completing the square, this area in here becomes 264.0625. So 264.0625. Okay, so now I need to balance this equation. So I've added 40 groups of that, so I times that by 40. So I've added negative, looks like 10,562.5. So I've taken that away, so I need to add that same amount to balance the equation off. Okay, so there's my balanced equation. I now have a completed square, so I'm going to factor this. So negative 40, that's an upside down parabola. The vertex is at 16.25, so x is equal to 16.25, and then our maximum revenue, if I add that all up, I get $85,562.50. So there's my vertex. The question was asking determine the best price to maximize revenue. So I get x equals 16.25, and then I'm going to use my price equation to calculate the best price. So my price equation is equal to 300 plus 10x, and we solve x is 16.25, so then our best price works out to be looks like $462.50. Okay, when I add that all together, so the price that maximizes the revenue is going to be $462.50, and the maximum revenue we can work out to be this $85,000 value here. Okay, and we can figure out the number sold again by we can plug in the x, and might as well do that. Although the question doesn't ask us to solve this, we can calculate the number sold using that equation. So 250 minus 4 times x, which is 16.25. So 250 minus 4 times 16.25. We end up selling only 185 tickets.